All right. Well, good afternoon. It's an honor to be here. Colorado is very beautiful. 100 years ago, my grandmother was here with her friend, and she got lost in a mountain and had to be rescued. So it's ironic that I'm here 100 years later. First of all, let me talk about my... Can you turn down that a little bit? Yeah, just a little bit. I've been programming since 1970. I started with punch cards, mainframes, went to workstations, PCs, mobile devices, built 80 iPhone apps, and have worked on the web for the last few years. I built a lot of graphical interactive software, painting programs for kids called Flying Colors, a Dragon Ball painting program in Japan. I did a label designer here. I worked on WordStar 2000 and DisplayWrite 5 Composer for IBM. So lots of desktop publishing, lots of graphical interactive software. The current situation in the world is that HTML and JavaScript and CSS are the three languages that are in the browser. And Google controls the browser directly and indirectly, and they have no interest in changing the way it operates. And I find that current stack overly complex. Never in history did we have to write in three languages inside the same file. Two maybe, but not three. And I mean, CSS, JavaScript, they don't even share a common syntax. I mean, HTML, how I hate thee. CSS is a horrendous system. It's a bizarre language which keeps getting encrusted with more features, and it has no clear spec, and so the browsers render things slightly differently, and it's the tiniest mistakes will cause your program to explode. So I want to replace this with a single language, and I want it to be simple, robust. I want it to be reliable. I don't want it to crash. I want it to be concise because I don't want to do a lot of typing. I want it to be like a shorthand. I want it to be for a professional person who wants to just get something done with the minimum amount of fuss. I don't want boilerplate. I don't want lots of extra punctuation and definitions. But above all, I want it to be graphical, which means I want the graphics and layout in the language itself. I don't want it as an add-on, because every time you put it as an external add-on in a language, then multiple graphical environments get created, and then you have schisms and battles over that. And you can see that in the Linux, they never resolve that. It's a never-ending battle. So what is the basics? This is an indie effort. It's free to use. It's in a commercially usable state. I've done about, 90 releases of it, and 58 official releases. What does it do? You could technically call it a transpiler. So you write in beads, this one language, and it spits out JavaScript as its assembler code. So the browser to us is a virtual machine that runs a JavaScript, and the browser is a sandboxed graphical environment. So you can do some things on the network, but you can't do others. You can't send a ping, but you can do WebSockets. So the browser gives you a certain set of functionality, and our standard library exposes about 90% of what a browser can do. The client-side JavaScript that it's generating, there's really three kinds of web programs. There's the regular document object model browser web page. Then there's the bitmap context, which is used for graphical, highly animated graphics. And that bitmap context, unfortunately, has completely different graphical primitives, something we solve in beads. And then the other one is the WebGL, which is for GPU-accelerated 3D graphics. I do not support WebGL. This is not a 3D product. It's strictly for 2D work. It's for a variety of reasons. On the server side, yes, it works with Node. And so when you get into the compiler, you can say, my target is Node, and then it will generate MJS files, which is the notation, the suffix they use in Node for ECMAScript 6 modules. Anyway, yes, it works in Node, and the server side can be done in other languages if you wish. This is intended for professional programmers. It's not a toy. it's a crude compiler. Use it with a plain text editor. There's no IDE. There's no VS Code integration. You're not going to get any of the helping hands and the crutches that you get in VS Code. But thankfully, the compile times are really fast. It's usually under 1 second, so it's basically instant. The trade-offs. One of the things that happens when you are generating your web pages on the fly at the client is that means when a web crawler for the search engines goes to the server and starts looking at all your JavaScript, it's seeing the code that generates your pages, not your pages. So you're not going to get any indexing. You're not going to get any search engine optimization. This is true of pretty much of any generative technology. And some people just create static dummy pages to grab the web search traffic. The runtime is reasonable. It's 400 kilobytes of JavaScript code, 150K zipped. It's just 2 files. Obviously, it prefers control over the screen and events, so you're not going to mix this with other things. And it is not suitable for heavy computation because of the tremendous overhead of the deductive engine that's inside it. It's not suitable for number crunching. Let me give show you an example of a source code so that you can get a feel for what a program looks like. So this is hello world. The first line of every Beads program, you have to say Beads 1, and that means version 1 of the language. It's sad that other languages did not put in a version number for the syntax they're expecting, because that way you can upgrade it in the future and forward convert it. If you ever get some old code and Beads has moved on to version 2, you can then forward convert it automatically. Here I'm defining a gradient. That's a structure of basically 4 colors, and you give them a stop position. That's how you define a gradient. And then the main drawing function, main draw, you draw a rectangle, and you say fill it with a gradient. And then you say draw a string, and you say hello world, and you say size 20 point, and you say indent it 10 pixels from either side, and make the size 72 point, and make the color chocolate, and use the font typewriter. So that is an example of how you build a program. It's in a text file. You do your definitions at the top, and then each little chunk of code controls a rectangle. In this case, I only have 1 block of code. You notice it says draw, main draw. Every chunk of code, every subroutine has a purpose prefix. Is this block of code going to calculate something, or is it going to draw something, or is it a finite state machine, or is it a tracking block for event handling? If you're in a drawing module, you're not allowed to change the global state, because that has to be a pure functional type of block of code. If you're in a tracking block, you're going to be updating mutable state, but you cannot draw. And if you're in a calculation function, you can only modify the mutable state or calculate a number, as a pure function would. So every function has a purpose that you say first. Let's go to the next. Let's talk about a flaw that HTML has that Beads addresses, which is localization. What if I want to do this hello world, but I want it to be multilingual? You would think that they would have made provision for that in the web, but no, they did not. And so we have added a slight change to the way you define a string. So here in hello 2, I say hello world, and then after the string ends, I have left bracket 1, like it's a subscript. And that is a string number suffix. So you write your program in English in the beginning, then you run it through a string scanner. It then assigns a unique number to every string in your program, and then you build your translation tables from that, and maybe you automatically translate your phrases and words, and then when you're done, at the very top of the program where I said lang, on the first line, I say lang, ing, lang, España, lang, Japanese. Sir, I'm telling it I expect to have the 3 languages translated available at the time I compile. So now when I run this program, and you can see here I am tracking an event. anytime, every block of code that it says draw owns a rectangle of the screen, and that rectangle is supplied by its parent. And obviously the topmost rectangle is your window in the browser. Immediately after each drawing block, you put your event tracking code. And this allows a person to figure out who's absorbing what click for what part of the screen. And here, if I get a tap, I'm basically cycling through the languages and telling the UI I want to switch my language. So now let's go back and run this program. And here, if I click on it, it changes the thing. So this is incredibly simple localization. It doesn't clutter up your code, and you're not adding extra function calls. Another example, this is actually a utility that you can freely use. This is a color picker. I think it's one of the best color pickers because it has repeatable colors. The central problem with the Adobe and Figma color pickers is you will not be able to get that color again if you come back the next day and you go, gee, I remember getting a really nice red. You're not going to find it again. But this, because I have these 700 color chips, were picked by Mark Ferrari, who's a super famous pixel artist. And then above those are the 214 HTML named colors. And on the left-hand side here, if you're programming in beads, you would say beads format. If you're programming in HTML, you'll want it as a hex color with a pound sign in front. Maybe if you're in plain hex, you don't need the pound sign. If you're in C, you want OX prefix. Or maybe you want it as an RGB function call, or HSL, or vec3 if you're doing 3D. So the purpose of this is you pick a color in this system, and when you pick a color, it has copied that string to the clipboard. So you go into the color picker, pick a color, and jump back to your text, your code file, and paste in the color. So we would change, if we wanted to change the color of something, I'll show you how I do that in a minute. Another example. Let's see. Okay. Color picker. Here is the mortgage calculator. Now, this is probably the greatest strength of beads is in its precision and ability to cram into a tight space. After I did all those 80 iPhone apps, I found that cell phones vary so much in size, especially on Android. There's 10,000 different Android devices on the market today. Not one of them has even 2% market share. So every possible shape and size exists. Now in the Apple world, you only have 5 sizes, so it's much more tractable and easy, and they're half the market in the United States. But the rest of the world is heavily Android-based, and if you're making a product for around the world, you really got to support Android as best you can, and it is quite a challenge. So the way you design in beads is by doing proportions, and by using proportions, it will kind of stretch out to fit the page better without a lot of extra, without having explicit coordinates. So beads is a layout system is very different than CSS. It's an outside-in with explicit white space, and I'll explain how that works in a minute. If we're looking at the example of this calculator, you will see that when you go into the Google Chrome tools, the Google Chrome Debugger option, down at the bottom there's this little icon that says, is this web or do you want to simulate a device? And if you say device simulation, I can say, show me what it looks like on the iPhone SE. And then say, okay, now show me how it's going to look on the XR. Okay, how about the 12 Pro? Okay, still looking good. And then the 14 Pro Max, that's about as big as Apple phones get. And then when it comes to Android, the ultimate phone for the Android in terms of size is the Galaxy S series, the Ultra S series, which is a very tall phone with tremendous resolution, over 500 pixels per inch. And of course, you can test then rotation. And you can see it's rotating nicely. It's using available space. It's giving you legibility. And that is very critical. In mobile apps, I see a lot of mobile apps where they are running 6-point and lower text. It's actually illegal under the American with Disabilities Act to run that small. You're not supposed to use tiny text, and yet people do it all the time. And the reason they do it is they're lazy and they're being conservative because they're afraid of spilling out, being too big. So they just make the text size small, and that way they never have a problem. But it causes legibility issues. Now, where is my presentation? I must have closed it. Where did it go? Oh, here we go. Okay. Another area where Beads is very useful is client-server. Here I built a real-time status monitor, so the server is checking the pinging various hardware nodes, and then the client is just drawing little green dots if it's been up for a while. Here I built another example of a kind of a real-time stock trading program. So I'm getting a feed from the server, and then the client is supposed to, draw this little like electrocardiogram graph of the price as it fluctuates. And I'll show you how you would run that. You would go into the console, and you would go node the server program .mjs, and now the node, the server is now running, and here the price is being generated. Now that console log is coming out of the server. Now I go to the client, and I go to the client, and I say connect, and now I'm getting the feed from the server over WebSockets. Now, if you look down at the bottom in the debugging section, you'll see that the server console logging is being echoed. So one of the nice features that I offer when you subscribe to a server feed is you have the option of saying, I would like to see the server messages inlined, interleaved with my own tracing so that I can see them time aligned. And that is a great convenience when you get into client server, because you've got two programs running at once and it gets tricky. Let's go to there, okay. Programs are made out of little tiny blocks. That is how you code. They're very small, very light nesting level, and every drawing block owns that rectangle. Now, unlike HTML and CSS, you've got if statements and looping in your layout. So it's much more natural and much simpler to work with. The fundamental unit you work with is not pixels, points, and picas, but rather aliquots, and those are proportional units. It's simpler than Flexbox and the other techniques in CSS. This is a fragment of a program, and let me try to explain how you do proportions. You use proportions when you make a cake. You go this many cups of flour, and then you go 2 cups of flour, 1 cup of sugar. You have proportions. That's the way all recipes are done. That's the way buildings were made, starting with Vitruvius in the 1st century. He used proportion-based layout when he designed buildings. He said it should be this many times this much of a fraction of the person's height for the doorway. And it was all human-based proportions. And that's why those buildings are so great, so human, and so nice looking. In this particular case, I'm breaking up the screen into 7 sections. I'm saying slice the screen horizontally, so I'm going to make slices across, and I'm going to skip 10 aliquots, 10 units of space, then 100 for the green, 5 for this gap, 120 for the red, 5 for a gap, 100 for the blue, and 10 for this gap. So you have 7 segments. 4 of them are dead space, but I am telling it how big I want the dead space. In CSS, you have this crazy thing. You have margin, border, and padding, and you're never sure where it's going to be, and it slides the blocks around how they feel. You are telling it how you want it subdivided. You can put maximums and minimums on this, and that means as the screen is getting bigger in this horizontal dimension, when you put a maximum minimum on it, you are actually creating a linear function that it's piecewise linear, that scales exactly how you want it. So as it in medium size, maybe the green bar gets most of the size, and then maybe later the red will get more. But you can create a very customized formula. And obviously this takes a lot of tuning to do. And mobile apps do take a lot of work to make right. But when you have correctly tuned your proportion formulas, you have a web app that will look great on almost every device. And that is something that is not easy to do. This is an improvement over the Apple struts and springs, which was in their interface builder tool, which they got rid of. You know, Apple has a nasty habit of just killing products when they get tired of them. Now, one of the other issues you have with generated products is you've got something on the screen and you don't like, it didn't come out right, or you want to change it for any reason. How do you know what part of your code made that, drew that part of the screen? If it was just static HTML, sure, it's right there, it's just text. But when you're generating your pages on the fly, like this system does, and like many systems do, that actually gets tricky. So let me show you how you would find out what part of your code. Let's say I'm in hello 10. What happened to hello? Let me go back to beads. And let's run it. And let's go to the debugger. So you go to More Tools, Developer Tools. Okay, and let's turn off, let's imagine we're still on a regular page. Here I go to the elements, and the elements are the div blocks. Every rectangle in the web DOM is a div block. And so I have to, let's say I don't like the purple of that mushroom. I want it to be blue. So where in my source code did I draw that particular thing? I first go through the elements and I see I'm hovering over the div and it's the second column. So it's in the second column, and then I expand the disclosure triangle, and now I see, oh, it's dfroggy. So dfroggy is the name of the function that drew that. So I go back to my source code for hello 10 here, and I see there it is, dfroggy block fill Rebecca purple. So there it is. I then would go to the color picker. So this is your standard workflow. I go to the color picker. Sorry, here we go. I would go to the color picker and I would say I want Dodger blue, and now that's copied in the clipboard. I go to my text editor, I double click Rebecca purple, and then I paste in Dodger blue. I save the file, and I go to the compiler and I say hello 10 compile. And you can see on the thing it took 0.016, so it took 2 milliseconds to compile it. 20 milliseconds, sorry. It's not that fast. So it recompiled it, and then I go back to the browser, and I go back to my hello 10, and then I refresh it, and now you can see it's blue. So that is your workflow. You edit in a text editor, you press compile, you get through your silly text typographical errors, and then you run it by refreshing the page in the browser. Okay. The event tracking code is right after the drawing. We mentioned that. Another nicety that is essential in mobile, but does not exist in HTML, and it doesn't exist in the iOS system either, is that they do not allow you to autosize. You've got to have the ability to shrink the text if it's going to go outside the box. Otherwise, you're going to truncate the text, which is very ugly, and you never know, especially if you're dealing with translation. German usually puffs up at least 20% in the horizontal. So you need to leave a little extra room, but the fact that the system is measuring every piece of text by default to make sure that it fit in the box you are giving it and then shrink it automatically if necessary is a tremendous convenience. It means you don't have to go back and keep tweaking all the sizes depending on how your program changes, because you rechange your window size a lot and you're changing your sizes as you're tuning your product, and it's just so much nicer to have a fallback, a safety that in autosizing. Now, what is the thing about the data? You've got your code, now you've got your data. Data, we only have one compound data structure. Lua has table only, and Beads has only a tree. So it is effectively a sparse, n-dimensional matrix of heterogeneous things. Every node in this tree can have a different kind of value. You can, and you index it through subscripts, and the subscripts can be an integer, positive or negative, or a string, and an enumerated value is actually a number in our data type system. So that you could call those symbolic numbers. But anyway, that every node already exists in the sense that you can have an address to it, so there are no RAM pointers in this system. Now, there are some benefits to this. First of all, you have no new and disposed. There's no objects with properties. And because you have paths to nodes from a starting point in a tree, that can actually be saved to the hard drive. You can save a path across the network, and it still is valid. And the other thing is a path can exist before the value does. So you can pass a path to a subroutine and say, please put a value in there for me. And then you don't have to deal with all this ownership stuff. I think that Rust went in the wrong direction in the sense of obsessing over ownership, because that isn't the main problem that I have coding, is who owns something. Now, because we've got this tree thing, this graph, I mean, it's really a graph, but everyone thinks of a graph as a chart, so I call it a tree. Anyway, you now have more than, because a node in a tree has children as well as a value, you have more possibilities for what operations you can do on that node. You could say, truncate the node, get rid of all the children, but leave the value alone. You could say, get rid of the value and the children. You could merge a tree into another. You could prepend a value and find a subscript that's the lowest one and go one more before that. Or you could go to the one after the current highest subscript. Or you could swap values between two nodes in a tree. So you have a new repertoire of basic operations. And the bulk of learning Beads, which takes about 10 hours to learn this new language, which is a lot of time to invest for people. You have to learn these operations, and these are all new. They don't exist in the languages you're familiar with. Now, one of the features of this tree is that I am keeping a kind of a timestamp on each node, and I know when you update a node, and I'm keeping track of that. So I know what's new since a certain time period. And first of all, by only having one compound data type, it's going to make client-server communication a lot simpler. Because when you start to have queues, stacks, bags, lists, all these things that other languages create, tuples, you're creating a whole set of incompatibilities, because now a subroutine has to accept one of those but doesn't accept the others. Because we only have trees, that means every subroutine that handles compound data types is pretty much going to be able to accept what you're sending. And now, in your basic event loop, you have some program state, some game state, let's say, like a chess game you're making, and you have the board. You have all 64 squares of what piece is on what square. And then you send that to the browser, and you create your browser DOM, and then browser renders it on the screen, and you've got your nice chessboard. Then the user clicks on one of the chessboard pieces and moves it to a new square. You've now updated 2 chessboard squares, right? Then you've modified the state during that event tracking. Then it has to go back and say, somebody has to figure out how much to redraw. Now there's 4 ways you can do refresh. You can redraw every frame, 60 frames a second, like 3D engines do in PlayStation and Xbox. That works if you've got a GPU and you're just going to brute force it. That's not going to work because browser engines are not a bitmap with binary. They don't have a GPU with a triangle sitting in VRAM. No, they are using a hierarchical tree of textual descriptions, which are then interpreted, decoded, sent back and forth to the GPU for some rendering subtask, and then collated at the end onto the CPU. It's an unbelievably complicated process. This is why browsers are 20+ million lines of code. They are very complicated under the hood, and unless you're doing OpenGL, which I'm not supporting, I'm talking about regular web apps, you cannot afford to redraw everything every frame. Your product will be brutally slow. If you manually schedule refresh, that means you have the burden of figuring out what has changed since the last time you drew. That is an incredible burden, and I can tell you that I have many commercial apps on the iPhone that have refresh bugs in them, where your stale data is shown on the screen. You just transferred $10,000 out of your bank account, and yet your balance still shows the money. It's like, why didn't it update the balance? Oh, because it forgot to refresh it. And if you quit the program and come back in, magically it's correct. Another way people do it is they rebuild the entire document object model, and then they compare new versus old. That is not a methodology for speed. Beads deduces which blocks need to be refreshed by tracking which state variables were used in each draw block. This automatic re-execution of the drawing code, what we are memorizing the parameter list for every draw call that was made last pass, and we have memorized those and saved those along with the tree. And therefore, if that subsection of the tree is dirty, I can re-execute just that section and its children. And this avoids a whole class of refresh bugs. Now, it does force you to be careful. You better not be updating state in your drawing, because then you'll create an infinite loop. Client server. This tracking, this versioning, this timestamping of every node in your tree has tremendous benefits when it comes to client server. Because let's say your server is your source of truth, and I've got this tree here, and I've got these nodes, and the 82 node is in that subsection of the tree has been sent to the client, right? And then the server changes that node from 82 to 83. The timestamp is updated, and I know last time I sent 82, that I was at version 100 of that data structure, and now I'm at version 101. The server knows to push the new node to the client. And because it's pushing on binary sockets, one node at a time, it will minimally transmit. So you have great performance in terms of updates. A lot of systems that are based in regular HTML with the JSON encoding and decoding, if you use the simplistic client-server subscription system, you don't have to do any decoding and encoding. It's all automatic by the runtime. The point of this is that you are getting a minimal transmission. So I'm keeping packet down, the number of packets down. And when you get into large numbers of users, the biggest thing you face is actually bandwidth, not horsepower. Because if you keep sending, MySQL stuff, a lot of people do queries, and it ends up sending all the records to the client. And then they change their query slightly, and then it sends it all over again, right? So you have lots of duplicate downloading in a lot of client-server environments, and I'm sure you have used apps that seem to be very sluggish upon a second and third change, when you make some minor change. The way you build a client-server program is you write in one file first as a single program, because you want to get the client-side rendering working right, because that's the hard part anyway. That's where most of the work is going to go. And then once you have the client rendering sample data correctly, you then split out that part of the code and put that on us in the server and then run it separately. When you're doing client-server work, in fact, when you're just running, you have to run this thing called a simple web server, because it's a free tool, and there are many others, and that creates a virtual server on port 8887 so you can actually load your own source code. Believe it or not, the browser's security model allows you to run JavaScript from anyone else's computer without restriction, but if you try to load JavaScript code from your own computer, Chrome blocks that under their core's security model, saying this could be dangerous, which is pretty nutty because it's your own code, for goodness sake, and you asked it to load it specifically. Anyway, that's just an annoyance that you have when you're working in the web. The data types and beads are very simple. Remember, JavaScript is our assembly language, so we can't add too many fancy things. I have one or two that are new. I have physical units of measure. I added these for the engineering people, which they don't seem to care about having. Anyway, I put it in anyway. It has all the physical units of measure that are commonly used, all the conversion factors, so you can say 3 kilograms but 2 pounds. And then you can create your own unit family, so you can say, oh, I want to use furlongs. And a furlong is in the family of length, and the way you define a furlong is the ratio of 1 furlong is equal to 220 yards. And then you can use that in your code. And the compiler will check the exponents of all the fundamental units using Fermat's technique for checking errors. So another nicety in the language is I hated the way JavaScript regular expressions, I mean, this goes back to Unix, the way they used escape characters and meta characters. So I gave you a vertical, it's a one-to-one replacement for the regular expression syntax that you would use in JavaScript, but instead I make it vertical and I stop using backslashes, and I allow you to have comments and I allow you to have subroutines. So you can make some pretty gnarly regular expressions that are, I claim, actually understandable. In this case, an email is a boundary with one or more of a set of characters followed by an @ sign with one or more characters from this character set with a period and 2 or more characters in the set A to Z. That's the definition of a valid email. And that's the same as that expression up above, which is brutally hard to figure out. We use closed arithmetic like Excel. This is somewhat controversial. You have a huge trade-off. I'm paying a great deal because I'm checking on every computation. Every time I multiply or divide, I'm having to check if either side is in a symbolic value or is undefined, and I have to catch that in the bottleneck routine. But it means the programs are robust and that errors will be caught. The tiniest error will be caught and propagated. So if you have an undefined variable, U is the symbol for undefined. If you have A times B and A is undefined, then that expression is going to be U. So the worst error is going to propagate. And that's how you do error propagation in the program. There's no try-catch, there's no crashing, there's no exceptions handling, no signals. We're doing the Excel method, which is keep running, but just kind of let people know that your value is garbage. The experience of using the program. There's only about a dozen functions that you have to learn. You have to learn the draw string, the draw rectangle. You have to learn how to maybe do an input field and maybe draw a line. So the standard library, solving for a rectangle is very common. a dozen functions will be 90% of all the standard library functions you call. There's about 200 standard library functions in the system. Like I said, it's very complete. And that actually is the bulk of the work in building the system, was debugging the standard library. And the quality of a standard library, in my opinion, determines to a great extent the quality of the language, because if you don't have a standard function library, a function that you need, you are sometimes hard pressed for it. The code, you have almost no boilerplate. There's no coordinates in it. Most functions have no parameters, so you have very low nesting level. You naturally get almost complete code coverage, which means almost every function in your program is going to be executed every single time, because you've broken down this tree, and each little block is going to probably get executed. You're much better off in these by having just a few large source code files. 90% of your code is going to be drawing code, and there's no point in splitting that out into many, many pieces, because you're just making it harder to find it when you're editing. At some point, after maybe 5,000 lines, it gets a little unwieldy. Maybe you want to split off libraries for your widget drawing and so on. Web apps, which is mobile web apps, take a lot of iterations to tune the proportions. But when you're done, your product is more legible and wastes less screen space, and I would put it up against anything that is made today. I think you could take any commercial product and make it better by tuning it to more efficiently utilize this screen space. In the future, I would like to see an IDE. I mean, right now it's very crude. You're just using a text editor. I'd like to have a IDE that has time travel. Here is I would like to have it have an index of all the functions. So the way you in Blockly and Snap and some of these graphical languages where you drag little icons onto your page and you gradually build a program visually, that would be a wonderful thing to have. This type of approach is amenable to that because you're writing in such a shorthand notation. It should be possible to make a visual programming interface for this language instead of having to type it in. This is how you would form a function call. You'd look it up in your dictionary of standard library functions, and you can say, okay, to upper converts it to uppercase, and it only has one parameter. Now that's not very interesting, but the to_stir function, that's the most commonly used string conversion, because you're converting a number to a string. And you need to know how many digits there are, and do you want to have a maximum number of digits? Do you need a minimum number of digits? Do you have a base? Do you want a currency character in there? Do you want to have a thousands mark for a comma? Do you want to have a K at the end, or do you want to have negative a parens if it's negative? Do you want to have a plus if it's positive? Do you want a percent sign at the end? Do you want a zero pad? Do you want to drop the trailing zeros? Do you want a currency? Do you want to override the currency character? All of those options have to exist. This is why I say the library is so important. There are many, many string conversion functions, including JavaScripts, that do not do half of these. And so you end up having to write your own every time. But you end up using all of these sooner or later. These are the ones that I've learned over all my years of programming that you got to have as a minimum in your string conversion routine. And in terms of the coding, I'd like to see, okay, wouldn't it be great if I could see this is all the cross-references between functions. I can see that this function called that function. And then I could drag in these keywords from my language and build my language visually. So it would be kind of a mixture of textual and graphical, iconic code building. And then when I'm done, I would like to be able to debug it with time travel and be able to go in reverse. I have an example of that. Let's see here. Animate one. So this is how I imagine in the future you would be looking at your entire code base kind of shrunk down into teeny little pieces where each one of these blocks maybe represented 10 lines of code. And so you'd see all your functions, your entire program at once, and you would see it calling the subroutines, and you would see it executing through, and you would be able to disable some loops so you don't waste your time watching something go over and over and over again. But the idea would be that then you could freeze it, go backwards in time, and see where your program went wrong. Time travel debugging is actually built into beads, but I actually never use it. And what I found out is that the only reason you needed time travel was because you were having trouble figuring out why your program did. But you don't really have that problem in beads very often. So time travel is not actually, does not pay off. It's just, you just don't need it. They do have time travel there was a product for C called the Omniscient Debugger that was maybe 15 years ago, a genius product. It was commercial. It was a special C compiler that when you ran it, you could run your program backwards. Incredible. And I don't know why it failed, because it was amazing. When you look at the videos of it, it's just astounding that they could do that at the time. Microsoft has time travel in their Visual Studio Enterprise version, where you have to buy some fancy license, and it takes gigabytes of RAM, and their approach is actually at the instruction level, where they're actually allowing you to single step backwards through the code one instruction at a time, which is unbelievably expensive, and of course has a brutal RAM overhead because you're accumulating all those. You're having to remember every instruction you executed. Anyway, that is my brief overview of beads. It's a challenge to go up against the mighty Google empire. They only have 180,000 employees and a 1.9 trillion market cap. So I've picked a very small competitor. Anyway, any questions? Yes?
In your layout system, you mentioned you do everything in proportional units.
Yes.
So you mentioned you do everything in proportional units in your layout system. Do you have the ability to put in fixed dimensions?
Oh, sorry, I should have mentioned. I encourage you to use proportional, but of course you will use points. Like, let's say you have a nav bar for some tool, and you're only going to need 100 pixels, or rather points. You should use points, not pixels, because you never know what a pixel means. If you're on a 500 DPI versus a 200 DPI device, you should get out of the habit of ever using pixels unless you're absolutely necessary. So if you say fix this size, then what it does is it subtracts all the fixed amounts first, and then whatever is left over is spread across the aliquots. So yes.
Because you mentioned you would go up against, say, Flexbox, but Flexbox does have the ability to grow or shrink contextually. So do you have those kinds of affordances in your system?
No. Our model is outside in. So each function is given a rectangle by its parent, and it is not permitted to grow itself. You can have a block that automatically sizes one dimension from trying to have it measure it, and that creates a second pass where it has to render it, and then it can place it. But under normal circumstances, the Flexbox, the problem with CSS is you can start outside in, and then you can put something in, and if it gets too big, it will push everything else out, and when it starts pushing, it's like elbowing boxes in crazy directions, and your page explodes. And in almost a stochastic, unpredictable way if you're not careful. Not Flexbox per se, but CSS in general is touchy, if you're not careful. Yes?
You said the tree was the one composite structure.
Yes.
What do you mean by a composite structure?
Compound. I mean, something that holds more than one value.
Do you have sums, like either type, something like this?
No. We do have the concept of extended arithmetic, because that's the way Excel does it, and you have the ability to create an enum value, a symbolic value, and you can say, and that acts kind of like a special number. You can't do arithmetic with it, but you can say that's an error value, or let's say you were coming up with some kind of exception. I mean, undefined and error are already base and top values for any numerical, any data type. So you have an extended, a sense that you can have multiple values for a single number, and it could be a symbolic value. But there's no way to, it's not like it's carrying around something else.
So I can't have, for example, a switch in my tree, where I say, no, here it's either a string or it's an integer.
No, you can't have it any type. You can put anything in the box. When you declare your data structures, it's a strictly typed language. So to protect you from a dumb error, you can say when you're defining your schema of your database that the address is a character string, okay? And if you try to save a number into that, it's going to give you an error, right? Because you're violating the type, and the compiler is going to catch that. But if you declare it as an any type, then it's open-ended, and you can put anything in there. You can put a bitmap, you can put a number, a string, whatever you want into that node.
Okay.
It's just that every node has a single value. That's all it can ever have. You can have nodes, have children, and you can have lots of nodes. You can keep adding subscripts, but that's the data model that it has.
Okay. And then my follow-up question to that is, do you have one tree? Is there one global tree for an application, or are you allowed to instantiate?
Oh, no, you have as many as you want.
What now?
You can have as many as you want.
As many as you want, and they're all do this capability of server-client tracking of.
Yes, now you can turn that off if you don't want the overhead, and you know it's a transient. Just say, turn that off because I don't want you wasting time tracking that thing. And also I consider it a transient variable, so I don't want it to trigger a refresh. So yes, you have control over that. You can have as many. Each of those is just an allocation at startup time where it's under the hood, it's creating a JavaScript object, which is the root node of a tree, and then you will add nodes to it. So.
Understood. That was it. Thank you.
Yeah, okay, thank you.
All right, let's thank our speaker, Jong, for his talk.